All right, y'all. So number one wants us to graph x squared plus 1. So I'm going to work that on paper, and then we'll come back and put our answer in MATLAB here. All right, so my match is number one, y equals x squared plus 1. So in MATLAB on this one, since we got that x squared term, we're going to use the 3-point x squared tool, okay? So on this x squared graph, the easiest three numbers to pick would be -1, 0, and 1. I'll plug each of them in and then see what I get from my y values. So first, I'm going to put in a -1, square that, plus 1. All right, kind of catch up with people getting logged in. So -1 squared is 1. So that gives me 1 plus 1, which equals 2. So the first point I'll plot would be -1, 2 on this one. Next, I'll put a 0 in for my x. So 0 squared is 0, plus 1, and 0 plus 1 gives me a 1. So then I'll plot 0, 1, and then finally let me put a 1 in. So 1 squared is 1. So I now have 1 plus 1, which will give us 2. So notice the U-shaped graphs are symmetric down here. I get the same value at -1 that I got as my +1. So I'm gonna come over here, -1, 2, plot me a point, 0, 1, so 0 up 1, and then 1, 2 would be right 1 up 2. And at that point, MATLAB's going to draw me a parabola. Now I'm going to do it on the calculator real quick, and then we'll go to MATLAB. So let me share my calculator. So you're on the calculator, you would go to y equals, put in your x squared. So my x, I'm going to square it with the x2 button, and then plus 1. So let me go to the table, because in MATLAB, you're going to need points. So hit second graph to pull up your table. And y'all, let me get some of these negative numbers. So there's the numbers I used. I used -1, got a 2. I did 0, 1, and then I had 1, 2. So now we want to look at the graph, because that's what we're going to have to put in MATLAB. So there's a parabola, looks like what I put on my paper. So now the trick is putting it in MATLAB. So let's go to MATLAB. So I'm going to click it to enlarge my graph. Remember, we're going to use the 3-point quadratic tool here. Click that. Now this one, it don't matter what order you put your points in. So I'm just going to go to -1, 2 first. So -1 up 2. Then I had 0, 1. So starting at 0, go up 1. And then I had 1, 2 for my last point. So right 1, up 2. Once you plot your 3 points, save that, and then move on.
Okay, so Mr. Eugene, I'm glad you going over this specific one because I wanted to ask you, how do you know when it's a 3 point or a curve? Like, how do you know which one it's going to be? I
Um,
had the most hardest time when we first did this
uh-huh.
with Math Labs doing
So
the graph right.
anytime you have the x squared graph like this one, I have y equals x squared plus 1. When you have that x squared term, it's going to be the 3-point quadratic tool every time.
And that's because it was x squared.
That's because of that x squared.
Okay, okay.
Mm-hmm. Now the next one, let me write this one down. Absolute value of x plus 6. So let's work that one, and then I'll sort of show you what to use on it. So I'm going to do y equals absolute value of x plus 6. Now this one, since it's got the absolute value bars, absolute value is going to be the V-shaped graph, and it's going to have 2 points on it. So that means you need 2 points, but y'all, it is very important that the first point we plot is the little point in that V right there. We call that the vertex. You got to plot that point first. So this point right here that you got to plot first is going to be the x value that makes this equal 0 inside. Okay, because that means it's going to be on the line. And that's what that first point in this section, that V point will be on this x-axis somewhere. So y'all, what x value would you put into that to make this thing equal 0 inside that absolute value? All right, so remember, since that's a positive 6, to make that a 0, x would have to be a negative 6. So you would have y equals absolute value negative 6 plus 6. Well, working inside the bars, negative 6 plus 6 will give me 0. And absolute value of 0 is 0. So y'all, the very first point I plot has to have a y value of 0. Then you can pick any other point you want for your second x, but you got to make sure the first one makes that equal 0. So I could use, say, a negative 5. I could use 0 here, 1, 2. It don't matter. So I'm just going to use negative 5 because it's right next to this one right here. So that'll give me negative 5 plus 6 inside my absolute value. Well, negative 5 plus 6 gives me 1. And the absolute value of 1 is 1. All right, y'all, let me let 1 in real quick. So my second point I plot would be negative 5, 1. But like I said, y'all, in MATLAB, you got to do the negative 6, 0 first. So come over here left until we hit negative 6 and 0. So it will be on the line. And then negative 5, 1, I come left to negative 5, go up 1. At that point in MATLAB, it's going to mirror your graph, and it draws this side automatically for us. So
go ahead.
Yeah, so this one is absolute value tool.
Got it. That's what I was just going to ask you. So absolute value will be a V.
And it's going to be a straight looking V, okay? So on the calculator, if you wanted to do that one on the calculator, let me show y'all that. So I'm going to go to y equals, and I'm going to clear that. So y'all, to get absolute value on this calculator, you're going to hit the math button, and then arrow right, and highlight number. Once you highlight number 1 right there highlighted, ABS is absolute value. So I would hit enter on that. And then I'm just, whoops, let me get back up there. And then I'm going to put in my x plus 6. And then I'll just arrow out of there. So now I'm going to do absolute value x plus 6. So let me show you the table. I would hit second graph to go to the table. Now you don't see any zeros yet, but notice my numbers are going to get smaller as I go up. So I'm just going to keep going up. And right there is negative 6, 0. So that's got the y value of 0. And then notice I did negative 5 and got a 1. But y'all, any of these numbers would work for your second point. First one had to be negative 6, 0. And then watch, we hit graph. Because see, y'all, this graph has to be over here touching that x-axis at that -6. So let's go graph MATLAB, because that's the picky one. All right, so I'm going to click to enlarge my graph. And you notice this V-shaped one up here in the corner says absolute value tool, and it's got 2 dots on it. So that's why we're only picking 2 points. So now I got to go down here and do my -6 over here. Whoops, looks like I hit a button already. So let me clear that. All right, grab my V, go over here to -6, 0, put my first point. And then I'm going to go to -5 and up 1. So y'all, that looks just like we drew and in our calculator. So if you put any other point first, it'll flip your graph upside down, okay? So you got to go with that 0 for the y value first. All right, yeah, let's see. You would hit next. So this next one, y'all, is this correspondence a function? So remember, for that to be a function, every member of the domain, which is my x values, can only have one y value, which is my range. So you sort of got to tell it why you think it's a function or why it's not a function. So y'all, this one is definitely, yes, a function, because all the domain, each member of that domain only has one range value. So we would have to pick, let's see, it's either A or D. So let me write. So it'd be A because the domain can only go to one range, okay? So you want A on that one. And then we would hit next. All right, so let me write this one down, y'all. So f of x, so this is our number 4. F of x equals 2x squared minus 5x. And notice they want us to find f of 0, f of -1, and f of 2. So I'll work that by hand, and then we'll come put our answer in. Now, if you want to put them on a calculator, you would just do 2, put a 0 in for the x and square it, minus 5 times 0, and so on. So I'm actually going to work them by hand. So f of 0 wants me to put a 0 in for these 2 x's. So I'm going to have 2 times 0 squared minus 5 times 0. And remember, we're only working the right side. This is just telling us what we put in for our x's. So you start with that exponent. So bring that 2 down. 0 squared would be 0 times 0, which is 0. And then I'm just going to bring down the rest. And now, y'all, anything multiplied by 0 is a 0. So that's going to be 0 minus 0, which gives me 0. If the x is in every single term or part, and you put a 0 in, you're always going to equal 0 for that answer. Then we had what? F of -1. So that's going to equal 2 times -1 squared minus 5 times -1. Now, this is how I would put it in the calculator right here. Put them negative numbers in parentheses especially. All right, I'm going to work it the same way. Exponent first. So bring down that first 2. -1 times -1 is a +1. And then I'm just bringing everything else down. And I'm wanting y'all to see that no matter what the number is, I'm working them in the same order, okay? So now here, 2 times 1 is 2. Here, since you're subtracting 5 times -1, that's going to be like multiplying 2 negatives together. That's going to make that a plus 5. And then our 2 plus 5 gives us 7. And then we got to work f of 2. So that'll equal 2 times 2 squared minus 5 times our 2. All right, so exponent first, so I'm gonna bring that 2 down. So 2 squared would be 2 times 2 is 4. And I'm just bringing the rest down. I'm going to multiply and multiply. So 2 times 4 is 8. Minus 5 times 2 would be minus what? 10. And y'all, 8 minus 10 would give us a negative 2. So on that, and we would go to MATLAB and put 0, 7, and negative 2. All right, so here I'm going to put my 0. Then we said 7. And then f of 2 was a negative 2. Okay, so throw them values in and hit next. All right, y'all, so let me write this one down. That is absolute value of 1. 1 plus the square root of an x. All right, so I'm going to work it by hand, and then I'll show you on the calculator, and then in our MATLAB here. So changing my numbers up, that's why I'm having to write them over here. So 1 plus absolute value x, and they're giving me the numbers. And y'all remember, since that's absolute value, that's going to be the 2-point absolute value tool when we hit MATLAB. Now, on this one, since it's got numbers added to the outside, when we get to the MATLAB, the first point we plot will be the middle point. And then I'll pick any of the other 4 points. But on MATLAB, that middle point has to be first. So that one's going to be first in MATLAB, okay? All right, so first we'll put a negative 2 in for that x. So that'll be f of negative 2 equals 1 plus the absolute value of negative 2. So I'm going to bring down to 1. So y'all, what is the absolute value of negative 2? Because remember, we don't care what sign they are in here. But
Is it positive 2?
It's going to be a positive 2. And then 1 plus 2 gives me 3. All right, then I would put a negative 1 into that. So f of negative 1 equals 1 plus absolute value of negative 1. Same thing here, bring this 1 down. Absolute value of negative 1 would be a positive 1. And then 1 plus 1 gives me 2. You'll notice these are going to be symmetric also. So once I get this middle point, this one should be a 2 and this one should be a 3 as we're going through them. So let's see what we get when we put a 0 into that. So f of 0 will equal 1 plus the absolute value of 0. Well, y'all, absolute value of 0 is 0. So I get 1 plus 0, which gives me a 1. So 0, 1 is the first point I'm going to plot in MATLAB. Now I'm going to put a 1 in. F of 1 will equal 1 plus the absolute value of 1. So y'all notice the absolute value of 1 is going to be the same thing we got up here for the absolute value of negative 1. So this will be a 1 plus 1, which gives me 2 again. And then, let's see, let me try that other one right here. That'll be f of negative 2 will be 1 Whoops, I mean f of 2. So f of 2 will be 1 plus absolute value of 2. Well, same thing. Absolute value of 2 is going to be the same thing as absolute value of -2. So this will give me a 1 plus 2, which gives me a 3. So these V-shaped graphs, just like the parabolas, they're going to be symmetric looking. So the -1 gives me the same thing as the 1. -2 gave me the same thing as a +2. But remember, MATLAB, 0, 1's the first point. So we come over here, 0, go up 1. And then 1, 2 looks pretty easy. So I'm going to go right 1 and up 2. Y'all, at that point, MATLAB's going to draw that V for us. So let's do this one on the calculator, and then we'll go put in our answer. But I want y'all to sort of see that these can be knocked out easy on these calculators also. So go to y equals, clear that. So remember, I don't want to get the absolute value yet. I want to put in that 1 plus first. So 1 plus. Now I'm going to get the absolute value. So you're going to hit math. Arrow over the number again. Absolute value is the first thing highlighted. So hit enter. And y'all, all we had to put in there was an X. So let's go look at our table. So second graph will show us our table. And y'all, they started with -2. So I'm going to arrow this down and get that -2 up there. So I got -2 gave me 3. -1 gave me 2. There's my 0, 1. And then 1 gave me 2. 2 gave me 3. And so on. Now let's look at the graph. So see, since they got that 1 in the front, this graph don't touch the x-axis no more. It's sort of up a little bit.
So did you plug in one number? Did you plug in all of those numbers or just the top 2?
Okay, so let's go to MATLAB because I'm going to pick 2 numbers to plug in. But let me write this down real quick. What do we get here? 3. Then I got a 2 here. I got a 1 here, a 2, and a 3. So you got to put them numbers in and then click to enlarge it. Grab that V-shaped absolute value tool. So the first number you plot will be your middle number where the X is 0. Because that's going to get me that V-shaped point there. So my first point has to be the middle point, which would be 0, 1. So I would go 0 and up 1. And then I would pick any other number. So I'll pick 1, 2. So let me go right 1, up 2. Because remember, our graph has to open upwards with our V, okay? All right, at that point, y'all, we're just going to hit save. So look, that graph right there looks exactly like our calculator did, okay?
Yeah, I guess it's better to know the points because the calculator, it can show you the where it goes, but it won't show you where to apply it, and that's where MATLAB's care about.
No, so watch this. Watch this. Let me clear that and just show y'all something.
Okay.
Now, this is if I messed up on this. So say I just went in order and I said, hey, -2, 3. I'm going to plot that first. So y'all, let me go -2, up 3. And then say -1, 2. Well, y'all, that don't look like my graph, does it?
No, and that'd be my problem. The numbers be right, but the graph be wrong.
Exactly. That's why you always, on this one, is really picky to start with that 0, 1 here. So y'all just remember, the third point is the first one you're going to use every time. And then it don't matter where you could have went -1, 2, 1, 2. Any of them other points will be right on those lines, okay? Yeah, MATLAB is really picky about y'all starting with that vertex on those absolute values for some reason. All right, y'all. Let me make this a little bigger. To tell if this is a function, you would use the vertical line test. And remember, for this to be a function, a vertical line cannot intersect that graph more than one time. So y'all look at all these vertical lines here. If you go up and down that, it's going to hit the top of the graph and the bottom of the graph. So let me go to my paper here. Right, y'all, if you're looking at this, vertical line right here intersects it here and here. I can do vertical lines right here, intersecting top and bottom. So this goes back to the x's having a choice. Remember, x's cannot have no choices but one. So if it fails the vertical line test, this is definitely a no. Remember, cannot intersect more than once. So cannot intersect more than one time. Now we'll use the horizontal line test later on in life when we do the one-to-one stuff. All right, y'all. So let's go in. MATLAB, we said no on that. So you just got to highlight the no and go to your next. All righty, so let me write this down. This is number 7. They want us to find the domain of g of x equals 3 divided by 7 minus 5x. Now notice they're giving me 4 answers to choose from, so let me figure out which one of them answers. So remember, on the domain, we're only worried about the denominator of a fraction. If it's not a fraction with a variable in the denominator, it would have been all real numbers. But y'all, we do have a fraction. So what I usually do is I take the bottom, 7 minus 5x, and I set it equal to 0. Because remember, 0 is what this cannot equal. So if we make it tell us what numbers for x equals 0, we can exclude that from our domain.
So why can it not answer equal 0?
Because if you had this 3 over 0, what does that equal?
0.
Oh, what did I just hear?
0.
Well, 3 divided by 0 is not 0. 0 divided by 3 is actually 0.
Oh yeah, that's right.
So what's this one?
3.
Starts with a U.
Undefined.
Undefined.
That's right.
And so if I had an X value and undefined was the answer, there's nowhere I can put that on a graph, right?
Right.
All right, y'all, here we go. Negative. So that's one of the only 2 things we're worried about in math. Undefined, and we'll look at it later on in life, but imaginary numbers is the other thing we're worried about. And I'll show y'all about them imaginary numbers, probably about a couple weeks. All right, y'all, so I subtracted 7, got negative 5x equals negative 7. Now I'm going to divide by that negative 5. So all these negatives make everything positive. So that's going to give me 1x. Ooh, that's going to be a positive 7 over 5ths. I cannot do anything to that. So in MATLAB, we're looking for an answer that says x such that x is a real number and x cannot equal 7/5. And we got to make sure we get to not equals, because watch this, as you look at MATLAB, they try to throw you a curveball or 2 on this. See, they got a greater than or equals. Well, I can't pick that one. I don't want B. So there I won't C, it looks like. X is a real number and x cannot equal 7/5. And y'all, that's something we'll play with all year pretty much, is like domains of these fractions and stuff. All right, y'all, let me write this one down. Number 8. F of x is going to equal negative 18x plus 15. G of x is a x squared plus 1. They want us to find f of 7 divided by g of 7. All right, so we'll work this and then come put that back in MATLAB. And I'll actually show you this one on the calculator also, okay? And I'll show you how to actually put it in as a fraction. Because I always set these up like fractions. F of 7 divided by g of 7. So f is on top. So we're going to have negative 18 times 7 plus 15. On the bottom, I'll have 7 squared plus 1. Now, y'all, here's the thing. If that would have been a negative 7, remember, I would have put that negative 7 in parentheses, okay? Because of that exponent. But since it's a positive 7, I don't have to use the parentheses. All right, y'all. So by hand, I kind of figure out what a negative 18 times 7 equals. That's a negative 126 plus 15 over 7 squared on the bottom gives me 49 plus 1. All right, so negative 126 plus 15 on the top gives me a negative 111 over 49 plus 1 is 50. So at this point, some of these are reducing and some of them are not. So let's see, 50, I know has what, 5s and 10s. That don't have that. 25 and 2. 111 don't have neither one of those. So I don't think that'll reduce. So we're going to go play with the calculator on this one. Now, right here where I got the negative 18 times 7 plus 15, that's the part I'm going to put in the calculator with the 7 squared plus 1. So y'all, let me show you how to do that. So let me clear this y equals out. I'm going to quit the y equals stuff. Now, to make a fraction, you're going to hit the green alpha button and the y equals. When you hit that, number 1 is ND. That stands for numerator over denominator. So now let's put in the negative 18 times 7. So I'm going to use parentheses for my multiplication. And then plus my 15 on top. Then I'm going to arrow down to the bottom. I had 7 squared. So 7 square that plus 1. So if you use the y equals, the green button and then the y equals, it makes it look like a fraction, and it's going to give me the answer in the most reduced fraction form. So remember, I had a negative 111 over 50, so we're about to see if that reduces. So no, y'all, it don't reduce because the calculator gave me negative 111 over 50. So let me go to MATLAB. Now, MATLAB, when you hit enter in the box, come down here and get the fraction. And I had what, a negative 111. And then that was over 50. So once we put that in, we're going to hit next. All right, y'all, let me write this one down. So f of x on this one is negative 3x plus 5. G of x is x squared minus 4. They want me to find g minus f of x. All right, so I'm going to do that by hand, and then I'll punch it in on that calculator. Unfortunately, this one has to be done by hand. So G minus f of x. So put these functions in parentheses on your first step. And then remember, put that minus in the middle. Now they want G first. G is x squared minus 4. F is a negative 3x plus 5. And y'all, I'll tell you about this problem. This next line determines whether you're going to get this right or wrong. So you're going to bring down that x squared minus 4. So do y'all want to tell me what comes next, what the next two parts will be?
Multiply everything in the second set of parentheses by 1.
Negative.
So
By negative 1.
Negative 1, there you
My
go.
bad, my bad.
So the negative times negative makes that a positive 3x. And then that negative times that positive makes that a negative 5. So distribute that negative 1, like y'all said, to both of these and multiply that. And now at this point, all you can do is add these numbers together. So write this in descending order with your x squared first. Then your plus 3x. And then we figure out what the negative 4 and the negative 5 equals. That's what a negative 4 and 5 is, negative 9. So really on this one, once you get rid of parentheses, all you're going to be able to do is add your two numbers together, bring down your x squared, your 3x, or ever how many x's, and then you're going to add them numbers to get that last term. All right, so MATLAB, I would hit my X, and then come down here and hit the gray box with the blue box by it. That's your superscript for your exponent, and then arrow right to get down and put in a plus 3x and then minus your 9. All right, y'all, you throw that in and go to next. All right, y'all, let me write these down real quick. So number 10 has f of x equals x squared minus 14. G of x equals 2 minus x. I'm going to find f minus g of a negative 8. So it's similar to number 9, but what makes it a lot different is it's giving you that negative 8 this time instead of an x. So they're not giving me an x this time, so f minus g of negative 8 will equal your f minus your g. F is going to be negative 8 squared. So remember, negative 8 gets its own parentheses when you square it. And then minus 14. G would be 2 minus x. That's going to be 2 minus a negative 8. So on the calculator, you would need this many parentheses if you used to punch that in like it looks. Now, this one, since I got numbers, I need to work inside my parentheses following my order of operations. So negative 8 squared, negative 8 times negative 8 will be 64 minus 14. So y'all, what can I turn this into? 2 minus a negative 8. So that would be what? 2. Remember, those two negatives now make a positive 8. So remember, just like you multiply negative times negative here, where am I at? This negative times negative made that a positive. All right, so now I can do the first parentheses. 64 minus 14 will give me 50. And I don't need parentheses anymore. Minus 2 plus 8 is 10. And y'all, 50 minus 10 is 40. So let me show you how to punch it in on the calculator. So let me clear all this over here. Whoops. Alrighty, so I would start with my parentheses. Since I got a -8, I'm going to put it in its own parentheses. So -8 in parentheses and square it. And then it was -14. Close my first set of parentheses. Minus, and then open up my second set of parentheses. Here I have 2 minus a -8. And close parentheses. So you don't really need this -8 in parentheses. I use parentheses on paper to separate the negative and the subtraction. The only thing you gotta have parentheses around on these negative numbers for sure is when you're squaring them, okay? All right, y'all, we should get a 40 out of this. So we hit enter and we get our 40. So then we go into MATLAB, put a 40 in there. And then we hit next.
Mr. Eugene, so for accuracy, would you recommend we do this one the calculator way or the by hand way? For accuracy, like to take no risks at all.
I would probably do it by hand first, and then maybe check myself on the calculator. Because remember, if you put one wrong key on that calculator, it might give you an answer, and it could be wrong if you didn't put the right signs or something on that thing. So, yeah, try them both ways.
I got it.
All righty, y'all. Domain of F divided by G. I'll tell you, me, I try to do everything by hand unless they give me crazy numbers like big, ugly decimals or something. Then I'm more prone to wanting to use my calculator.
Okay, that makes sense. It's just that you done taught us so much calculator stuff. I like the calculator. It's like, who cares?
Exactly. Well, that calculator can do probably 90% of this test. The only times it can't really do them is when I'm given those X's or maybe these domain things, but other than that, it can. So, y'all, we're going to determine the domain of F divided by G. F is 2x minus 7. G is 7x minus 35. So, I'll probably do it by hand to start. So, remember, F divided by G. My F is on top, 2x minus 7. My G on bottom, 7x minus 35. So once again, I'm only worried about the bottom of my fraction, remember, and it cannot equal 0. So I'm just going to set 7x minus 35 equal to 0 so that I can solve it and see what this x will equal. Once I got my x, I'm going to kick it out of my domain. So y'all here, let's add 35. So 7x will equal that 35. And then I'm going to divide by 7. So let's see, that gives me a 1x over here. 35 divided by 7 gives us a 5. But y'all, let me show you the difference. While ago, remember, they gave me the whole answer. This one will be, what they give you on this one is x such that x is a real number. And blank. They're not giving you the whole answer. So what you got to do, remember, since we got a 5 for this, we know now that the x cannot equal 5. So in MATLAB, you physically got to write x cannot equal 5. And then they'll have the parentheses. So y'all, let me show you what I'm talking about on that. See, they got x is a real number, but since this is a fraction, you cannot put b. So you got to click A, and then see how they got the box. Right here, we got to go X. And then let's see that not equals is down here on the bottom. So highlight that. And then what I get, I got a 5. See, So if you accidentally put not equal to 5 and you forget the X, or you put a 5 there, you'll have to email me and I can fix that for you. But yeah, they want that whole thing there. Okay, composition of functions. So this is number 12. We're going to have f of x equals 4x plus 7. G of x will equal x to the third. I'm going to find f compose g of a -4. All righty, so, and I'll show you how to do this one on the calculator in one step pretty much. But remember, on this one, the -4 goes into the G equation first. Once we get that answer, we'll put it into the F. So the G of -4 is the first thing we're going to find. So y'all, that'll be a -4 to the third power. So -4 times -4 is what? 16. 16 times -4 gives us a -64. So since G of -4 equals 64, that 64 now goes into the F equation. So you're going to find F of a -64. So that'll be 4 times -64 plus 7. All right, y'all, so let's see, what is 4 times a -64? That's giving me a -256 plus my 7. So -256 plus 7 gives me a final answer of a -249. All right, y'all, so let me show you the calculator, a quick and easy way on this calculator. I'm going to clear everything out. So since the G is going into F, I'm going to start with the F equation. 4 times X. But remember, the X for this is going to be the whole G function. The G function was X to the third. But remember, they gave me a -4 to put in for that X. So on this one, I would do -4, close parentheses. Whoops. Okay, let me start over. 4 times X on this one would be -4, close parentheses and cube it. And then arrow down and put your +7. So see, since G's going into F, I can put that -4 to the third in for the X on the 4X plus 7 and do it all in one step. And when I hit enter, I should get what? -249. All righty, so let's see, MATLAB.
Wow, so you really mean to tell me that that equation is has had the answer the whole time? This F of X.
Yeah, I mean it is, but you just got to remember for the F of X, you're putting that G in there, that X to the third.
Yeah.
But they gave us a number -4, so you're just putting in -4 to the third for that X and be done.
But it's y'all just about to say it's almost as if you didn't have to do the X cube. You literally just put that in there and you got -249.
Because that -4 cubed was that X cubed. But see, we're just doing it all in one step and sort of trying to do two steps.
I see. Okay, I see. Okay. Oh, okay.
All righty, y'all. So this one, they want to know if this is 1 for 1. Remember, 1 for 1, we did the horizontal line test. And if a horizontal line test can intersect this graph more than once, it's not 1-to-1. So I'm gonna, let me pull up my other paper here. So if you notice on this, if I start drawing horizontal lines, intersects it twice there, intersects it twice here, intersects it twice here. So since this is intersected more than one time, this is not 1-to-1. So you just come down and put no. Remember, to be 1-to-1, it can only intersect a horizontal line one time. So just like the function was the vertical line test, it's yes if it's 1. If it's anything other, then it's a no on those, okay? So y'all let me go to MATLAB. Put no on that. And y'all going to notice a lot of similarity on these questions when y'all do this. Alrighty, y'all. So let me write this one down. What is this? 14. F of x equals 8 over x plus 1. So guess what? When it says, is this function 1-to-1 on number 14, you better put yes no matter what. Every one of our number 14s is going to be 1-to-1. So what that means is we got to find the inverse function. So let me go to my paper. So f of x equals 8 over x plus 1. So we're going to find the inverse. So to find the inverse, I need to change this f of x into a y. So that I get y equals 8 over x plus 1. Because remember, I can't solve for f of x, but when I turn it into a y, then I can start solving this. So do y'all remember what I did next when I was finding the inverses? It's probably the main step that you got to do.
Would it be to flip the x and the y?
It would be, so that you get a x equals 8 over y plus 1. Now y'all watch this. The next few steps I'm going to do, all I'm going to be doing is flip-flopping this y plus 1 and this x. Because I can't solve for the y while it's in the bottom of a fraction. So remember, to get rid of the fraction, you would multiply both sides by y plus 1. So we can't do nothing over here yet. So that's going to be y plus 1 times x. But y'all look at the fraction on this side. That fraction now cancels. All that's left is the 8. Now, some people would distribute the x into the parentheses. But y'all, to me, that's doing a longer process. What I would do to this is I would divide both sides by the x. Because now these x's cancel. All that's left is the y plus 1 equal to 8 over x. So y'all remember up here I said all I'm going to be doing is flip-flopping them. Well, look here, the y plus 1's up here where the x was, and the x is down here where the y plus 1 is. So that'll work every time, flip-flopping those. All right, y'all, one more step. We got to subtract 1 from both sides. So that cancels. I got my y equals. So these are not like terms. So that's just going to be 8 over x minus 1. And then the last step officially would be to turn the y back into the f inverse notation. F negative 1 of x. MATLAB will give you that. All we got to do is put in our answer, which was 8 over x minus 1. So y'all, let's go look at MATLAB. See, they're already giving me the f negative 1 of x. So I'm going to hit the fraction and put in my 8 over x first. And then I'm going to arrow right out of that. And I had, what, a minus 1. Okay, so all you got to do on that is technically put the answer in the box.
And Mr. Eugene, another thing, I think I'm trying to see if the way I think about it is correct. When I did these, I noticed that a lot of times when they are 1-to-1 and it says yes, like you said, the answer is just like a reverse version of the first one. So you see how the top says 8 over x plus 1, and
Uh-huh.
that says 8 over x minus 1.
Yeah.
And is that a good way to indicate that? Because that's how I be like, okay, I just think like, okay, it's reversed, so it is a 1-to-1.
So yeah, you'll notice whatever you have on your top number will be on top of the x when you're done.
Okay, yeah.
And then you'll have that minus 1 at the end, or whatever's being added to the x will be pretty much what's being subtracted on it.
Okay.
Yeah, see, that's what I'm saying. You can find little patterns on this thing. Alrighty, what's this? 15. So let me write this down. 4x plus 3y equals 48. 3x plus 4y equals 50. So y'all, I'll work this by hand and then I'll show you on the calculator. So are any of y'all having fun doing these by hands, or are y'all doing the matrix?
Calculator. These are long problems.
Yeah, the 2 ain't as quite as bad as the 3. So is anyone doing them by hand?
I am, because I don't have a calculator yet.
Oh, okay. Well, you know
I've been
what? You
doing-
Good job, girl. Good job. You're going
Well,
I've
for
been
it.
doing them by
well-
hand because I don't really like the calculator. But
yeah. So, but I will say, if you don't have a calculator, download Calculator 84 out of your app store on your phone, and it'll be the same thing pretty much. Alrighty, so y'all, X's or Y's, eliminate what? What do y'all want to eliminate?
Why?
All right. And look, both of them got 4s and 3s, so it really don't matter on that, does it? Oh yeah, so y'all read Katie's message. She does them both, but you can download an app for like $3.99. She said to get an upgraded version. And it does just like mine, okay? All right, so to eliminate the Y, both of these rows have to change. I got to make one of them negative, one of them positive. So what's the smallest number we can turn a 3 and 4 into? Almost like least common denominator. What's the least common denominator between a 3 and a 4?
are you looking for 12? Or
Am I hearing 12s?
I said, yeah.
All right, so I'm going to make this one positive 12 and this one end up as a negative 12. So the top row, I'm going to multiply everybody by 4, because 4 times 3 will make that a 12. Down here, I'm going to multiply this row by negative 3, because that'll make that one a negative 12y. So let's see what we get. 4 times 4 is 16x. 4 times 3 is 12y. And let's see, 4 times 48. That's going to give me 192. Down here, negative 3 times 3 is negative 9x. Negative 3 times 4 is negative 12y. Negative 3 times 50 is a negative 150. But y'all look at that. 16 minus 9 gives me 7x's. The y is canceled. And 192 minus 150, oh, what's that? A 42. So one variable, I can now solve that for the x by dividing by 7. So I now know x is going to be 6. So I can go back to either one of these equations, plug in my 6 for one of the x's, and solve it for the y. So, they both look about the same. So I'm going to go to the first one and back substitute. So I'm going to do 4 times my x, which was 6, plus 3y equals 48. So y'all, let's see. 4 times 6 is 24, plus 3y equals 48. So remember, your first step when you plug that number is to multiply by whatever is in front of that variable. All right, y'all, I'm going to subtract 24. So my 3y is now going to equal, what's that, 24? And y'all, we divide by 3, we will now know what that y equals. So let's see, that cancels, and y is going to be, oh, what's that, a positive 8. But remember, what gets a lot of people in MATLAB, it has to look like an ordered pair with your x coordinate first and then your y coordinate. So on 15, it does not give you the parentheses in MATLAB. So when you, and see under it, it says type of ordered pair. So you have to do your parentheses, put in your 6, comma, 8, and then close those parentheses. All right, so that's 15. Y'all know we got the big one coming up next, right?
Love these.
So let me write this one down. This one, oh, y'all, I didn't show you that on the calculator. Hang on. Let me go back to 15 and do it on the calculator real quick. All righty, so let me share my calculator. So I'm going to clear everything out. So I'm going to use my matrix on there. So the first thing you do, you're going to hit second, x -1 to pull up your matrix. You're going to arrow right to edit. I always use A for mine, so let me just hit enter. Now remember, this is 2 rows by 3 columns. So hit your 2 enter and your 3 enter. So anytime you got an X and a Y only, it's going to be 2 by 3. And then I had a 4X, so I would put a 4 enter. 3Y would be 3 enter. And then 48 for the first answer and enter. So we don't put the variables because the matrix knows that the first column is your X's, second column is the Y's, and the third one is our answers. All right, this row I had 3X, so 3 enter. 4Y, so 4 enter. And then that row equaled 50. So once you put 50 in enter, all your numbers are up there in the rows. Hit second mode so that we can quit the screen. So now matrix A is that 2 by 3 matrix. So now we hit second, x -1. We're going to arrow over to math. And remember, it's going to figure out everything for us. So do y'all remember what I'm going to arrow down and find?
RREF.
RREF. So let me go down. So there's my RREF. So hit enter. All right, let's go back and get the matrix. So second, x -1. So mine's on A already. So I just hit enter. And then enter. Now remember, the right column is your answers in alphabetical order. So that means my 6 is my X and the 8 is my Y. So calculator a little quicker than me by hand, right?
Absolutely. My best friend.
I heard that. Oh, y'all, let me write my problem down. Let me go back to MATLAB. I forgot to get that next problem. So we hit next. All righty, y'all. So let me write this. 8x minus y plus z equals a -48. 2x plus 2y minus 3z equals negative 12. And then x minus 3y plus 2z equals a negative 6. All righty, so I'm gonna do it by hand first, and then we'll knock it out on that calculator. Now, y'all, when I do these ones so that y'all can keep up with me, I'm gonna label this equation 1, 2, and 3. Now remember, on this one, since I don't have any missing variables, in order for me to eliminate any of my variables, I gotta add stuff together twice, and I have to use all 3 rows by the time it's said and done. So y'all, on this one, I would probably pick the Y's or the Z's to eliminate. The X's looks like they wouldn't be too bad. Yeah, they're not too bad because you got an X here. So y'all, we got to eliminate one of these variables first. So X, Y's, or Z's. Oh, and y'all, none of them will be wrong. So what y'all feel like getting rid of?
X.
So we're going to eliminate the X. So since this one has just the X here, I'm going to add the 2 in row 3 first. But since this is the X and this one's a 2X, what are we going to multiply the third row by?
Negative 2.
Negative 2. All right, so we're going to add 2 and 3, and then we're going to change 3. Okay. So first, let me bring down 2, which was 2x plus 2y minus 3z equal negative 12. And y'all, we're going to multiply this whole row by that negative 2. So I get a negative 2x positive 6y negative 4z equals a positive 12. All right, good job. The x's are gone. 2 plus 6 gives me 8y. Negative 3, negative 4, give me negative 7z. Oh, y'all look at that. Negative 12 and 12 gives me a 0. So this will be my equation 4. So now I got to find my equation 5. So let me erase that now. So this time we got to use the first row. No matter which one of these two you pick, you got to use the first row. So y'all, we can either multiply the second row by negative 4 and turn that 2 into a negative 8. Or we can take the last row and multiply this row by a negative 8.
Do the third one.
Do the third one. So this time we're going to multiply all them by what? A negative 8. So we're going to add 1 and 3, and we're going to change 3. So one of these will always get used twice because we got to use them all 3 times, okay? So let's bring down 1, which was 8x minus a y plus a z equaled that negative 48. Now let's multiply this row by that negative 8. So I get the negative 8x plus a 24y minus a 16z. Woo, that's what, a positive. Oh my God, look what's happening again.
48.
Yeah, the 48 is going to cancel again, so that's cool. All right, so negative 1 and 24 give me 23y. 1 and negative 16 give me a negative 15z equal to 0. So y'all, that's my equation 5. Woo, we got an ugly one here. MathLab didn't like me today.
I thought my calculator was broke.
23y minus 15z equals 0. So I brought them 2 down. So, woo! I got to find either the I'm gonna tell you what. I'd probably do the Z's this time because 7 and 15 is a little bit smaller than that 8. So what I'm gonna do, since that's my row 4 and 5, on this one I'm gonna add 4 and 5, and I'm changing both rows. So I'm gonna tell you a trick I do to this. Now remember, one of these got to be positive, one of these got to be negative. But since I got to change both rows, I'm just going to multiply this row by 15. And let me see, I'm going to make the top positive. So I'm going to multiply this row by negative 15 and this row by 7. So if you don't want to have to worry about finding a common denominator, and I want to get rid of the z's, multiply this one by 15, this one by 7, and then you got 15 times 7 here, 7 times 15. So,
All right, I'm getting
cancel.
confused on this one.
Say again.
I'm getting a little confused on this one. I'm with you all the way up till we're right here when we got to change both rows.
Well, because 8 and 23, there's nothing I can do to that 8 to make that look like a 23.
Okay.
So I'd either have to change both of these numbers, and over here I got a 7 and 15. There's nothing I can do to the 7 to make it look like a 15. So what I'm actually having to find here is what's the smallest number. Both of these are going in.
Just like we did at the top, we're starting all over again.
Yeah,
Okay.
we're starting all over, but
All
now
right.
we don't have a 3 by 4. We got a 2 by 3 we're playing with.
Right.
So here we're actually going to get rid of the z's. So we're going to eliminate that z. But now you could have done 23 and 8 on this one, okay? Either way.
Right.
All righty, y'all. So I got negative 15 times 8, which is negative 120y. Negative 15 times negative 7 is a positive 105z. And then 0 times anything is just a 0 there. Now we do that to this row. 7 times 23 is 161y. Minus, well, I know 7 times 15 is going to be what? 105z. And then 7 times 0 is a 0. All right, so let's see. 161 minus 120. That's going to give me 41y. The z's cancel like we needed. And that's going to equal 0. So y'all, since we was getting all these zeros, one of these variables had to be a 0, right? So we'll divide by 41. So that cancels, giving me my y. And look at that, y is definitely equal to 0. So since you know y is 0, I can either go to this equation or this equation and solve for the other variable. So y'all, I'm getting a lot of zeros on this, ain't I? I wonder if I wrote all my equations down right. All right, let's see. Y equals 0. I'm going to plug that in, let's say 8 times 0 minus 7z equals 0. So y'all, 0 minus 7z equals 0. Oh, I can't believe all my variables would be a 0. But when we divide by negative 7, I get z is 0. All righty, so if y and z equals 0, so, oh, look at this. One of them that might not equal 0. So I'm going to use this one. 8x minus 0 plus 0 equals negative 48. So I'm going to plug in for that y and z. So I got 8x minus a 0 plus a 0 equals negative 48. Well, zeros cancel pretty much. 8x is all that's left. equal to the negative 48. So y'all, I guess I got one letter that ain't a 0, right? So let's see. That gives me my 1x, and that's going to be what, a negative 48 divided by 8 gives me a negative 6. Now, when we do MATLAB, it's already got the parentheses. All you're going to do is come in and put your numbers. Negative 6, 0, and 0. So y'all, let's go to our calculator. I'm going to go to my original equations and punch these things in that calculator. Because sort of sketchy when you get 2 zeros like that. So let's see what the calculator says. Remember, matrix, second, x negative 1, go to edit and enter. So 3 variables. So this will be a 3 by 4. So do 3 enter and 4 enter. Remember, 3 rows by 4 columns. All right, y'all, let's see what we had. We had an 8 enter, negative 1 for the y, since it was negative y.
Why did we pick the 3 by 4?
Because when you got 3 variables, you had an x, a y, and a z, it's going to be a 3 by 4 matrix, which means you got 3 rows, because I had 3 different equations. And then you got 4 columns. You got the x's, y's, the z's, and then the answers. All right, y'all, this was what, a 1z enter? And the answer on the first row was negative 48. All right, I'm going to hit enter. Next row, I had 2 x's. So 2 enter, 2y, 2 enter, negative 3z, negative 3 enter, and then that equal to negative 12. All right, my last row was 1x, negative 3y, 2z, and then that row equaled negative 6, and enter. So we got all those numbers in there. So remember, quit the screen by hitting second mode. Go to second x negative 1. This time we're going to math. Let's go get RREF. Hit enter. And then second x negative 1 for the matrix again. I'm going to grab my matrix A we just made. So hit enter. And y'all, we're going to hit enter and pray we get a negative 6, 0, 0. And y'all, there it is. Negative 6 would be my x, 0 would be my y, 0 would be my z. So even when you're working them and you get some wild answers, verify it on that calculator if you want to. Now watch how MATLAB does. See, they give you the parentheses on this one. So we're just going to come in and put our negative 6, arrow over and put our 0, arrow over and put our 0. All righty, y'all. So on this one, I'm going to make an egg column because eggs is going to be my X's. Cupcakes will be my Y. Pizza will be my Z. And then the milligrams of cholesterol will be my answers. So let me show you what I'm doing before I put all these numbers in here. So I'm just going to sort of separate what each column means. So my eggs will be in the first column, then my cupcakes, pizza, and then the milligrams. So let's see what we're putting in. So the first row, 1 egg would be 1x, plus 1 cupcake would be plus a y, plus 1 slice of pizza will be plus a z, and that row is going to equal 300. So x plus y plus z equals 300. But look at the second row. 3 cupcakes. 3 cupcakes will be 3y plus 4 pizza would be 4z. And that row is going to equal 90. And then the last row has 2 eggs, so that'll be 2x. And 1 cupcake, that'll be 1y. And that row is going to equal 564. All right, y'all. So I got all of our numbers wrote down. So we're going to go to our pad and solve these. Now, these ones ain't as bad. Although there's 3 variables, since I got some missing variables here, it makes this one a little easier. On this one, I would either eliminate the x's or the z. Because if you eliminate one of those, this will automatically, one or the other will become the second equation. So y'all, I'll show you what I'm talking about. So, am I going to eliminate the x's or the z? What y'all want?
X.
You always like them x's. That's cool. So check this out. This is equation 1, 2, and 3. If I'm going to eliminate these x's, what are you going to multiply this first row by?
-2.
-2. All right, so we're going to add 1 and 3, and we're going to change equation 1. All right, y'all, so that's just going to double everything and make it negative. So you're going to get a -2x, -2y, -2z equals a -600. Row 3, I didn't have to change. That's 2x plus a y equals 564. All right, good job. The x's are gone. -2 and 1 give me a -y minus my 2z. And let's see what that gives us. That's what, a -600 plus 564 should be what, a -36. So that's equation 4. So remember, we just used 1 and 3 to get rid of the x's. Well, guess what? Equation 2 doesn't even have an x. So equation 2 becomes my equation 5. Equation 5 will be 3y plus 4z equals 90. So see, this one you didn't have to pick this row and another one because it's already got rid of the x's. Okay? So we put these two together now. So -y minus 2z equals -36. This one has a 3y plus 4z equals 90. So remember, this is row 4 and 5. So y'all, that's the difference. On the problem 17 or whatever it was, you didn't have a row with just 2 of the variables, so you had to eliminate the x again. But like I said, since this one don't have an x, it became my second equation. So right here, what do y'all want to eliminate? Y's or z's?
Y's.
All right, so let's see. That's a 3y. That's a -y. So I'm going to multiply row 4 by a 3. Okay, so I'm going to add 4 and 5. And this time I've only got to change my equation 4. So we're looking out on this one. So I didn't have crazy numbers like that 7 and 15 I had a while ago. Okay. All righty, so watch this. -3y. -6z equals, let's see, -36 times 3 is a -108. This row stays 3y plus 4z equals 90. But y'all look at that. The y's cancel all that's left are the z's. So you get -6 and 4 is -2z equals a negative, what's that, 18? So now we're about to have our z because we're going to divide both sides by -2. Well, that cancels and I get z. Negative by negative makes that a +9. So back substitute that 9 into one of these two equations. So I'm going to do this one as positive. So I'm going to do 3y plus 4 times z, which is 9, has to equal 90. All right, y'all. 3y, 4 times 9 is 36. All right, bring down that 3y. We're going to subtract 36. So 3y, those cancel. Ooh, let's see. That's what 90 minus 36 is 54. And y'all divide both sides by 3. So let's see. 54 divided by 3 is 18. So now I know two of my variables. So y'all, I'm going to plug them into my first equation. And I'm going to back substitute for one more time. I'm going to back substitute in the first equation. I had x plus y plus z equals 300. I don't know x, but I know y is 18. I know z is 9. And all three of them are going to equal 300. Now, if you remember about homework, your eggs were always in the 200 range. Your cupcakes were always in the teens, and the pizza was usually in the single digits. All right, I'm going to add 18 and 9. That's going to give me 27, equal to my 300. And then my last step, subtract 27 from both sides. So let's see, 300 minus 27 is giving me 273. So remember, I had eggs were my x's, cupcakes was my y, pizza was my z. All right, so remember them three answers because we're about to do this on the calculator. So let me clear everything out. So second, x -1, edit. And remember, you got three variables. So it's going to be a 3 by 4 again. So enter on the 3, enter on the 4. So the first row, 1 egg, 1 cupcake, 1 pizza. That'll be 1 enter. Whoops. 1 enter. 1 enter. 1 enter. And that first row equaled 300. And enter. Now y'all listen to my second row. I had 3y plus 4z equals 90. So what is the first number I'm going to have to put here
0.
for the x's?
0.
0. Good job. So 0 enter. Then my 3y, so 3 enter. 4z, 4 enter, and that one equaled 90. And enter. And then remember, for my last row, I had 2 x's, 1 y. There wasn't no pizza, so that z would be 0. So here we go. 2x, 1y, 0z, and that one equaled 564. Enter. All right, y'all, we got our numbers. So quit the screen by hitting second mode. Go second x -1 to math. And we're going to get to RREF. enter, and then go get the matrix, second, x negative 1, and enter. All right, y'all, so we're looking for like a 273, 18, and 9. There you go. Now notice on MATLAB, it says, hey, with the eggs, so with the eggs, we would put our 273. Cupcakes was the Y, that was 18. And then the pizza was 9. So your values will all be around this. You'll have 2 something for the eggs, probably a teen number for the cupcake, and then a single digit usually for the pizza. But it could be around 10 or 11 for that pizza, so it's always going to be in that order of size, though, okay? All right, y'all, let me write this one down because this one's going to take we're going to solve this first, and then we'll actually be able to plot it. So we're going to graph 18 is 3x minus 4y less than or equal to a negative 8. All right, so you got to solve this for the y. That way, if you wanted to use a calculator, you could, or it's easier to pick your numbers. So first of all, you subtract 3x to move it over. So bring down to negative 4y less than or equal. You can't add these together, so usually I'll put my x's first and then subtract my 8. But it wouldn't be wrong if you did negative 8 minus 3x. All right, so here's the tricky part on this. We got to divide everybody by negative 4. Remember, since I divided by negative, y'all, the most important part of this, reverse that inequality because you're dividing by negatives. So the less than and equals now becomes a greater than or equal. So that gives me my y greater than or equal. And all these negatives are going to make everything positive. So 3/4 I can't do nothing with. But here, 8 divided by 4 will give me what? A positive 2. Now, if I was doing this by hand, the 2 numbers I would pick for my x would be 0 and 4. Because of that fraction, I'll always pick my second x to equal what that denominator equals.
And
But y'all watch this. I put a 0 in first. Well, y'all, 3/4 times 0, that's 0. And 0 plus 2 equals 2. So when x is 0, y is 2. Now let me show you why I put a 4 in here. 3/4 times 4 plus 2. What y'all looking at? I picked a 4 because the 4s now cancel out. And all that's left is 3 plus 2. And 3 plus 2 gives me a 5. If you pick a 1, 2, or 3, you're going to have to graph a fraction. Okay? So I got 2 points. I'm going to go to MATLAB. So let me go at about 5. So 0, 2, 0, up 2. And then 4, 5, I would go right to 4 and up to 5. So y'all, the question is that line going to be solid or dotted? And I'm looking at that greater than or equal.
No,
Solid.
it's gonna be solid. My bad.
It's going to be definitely solid because remember, anytime you got equals on it, it's solid. And then I'm looking at that greater than to figure out if I'm going to be above the line or below.
Above.
Above. So when we're done, it should look like that. So MATLAB. So I'm gonna click to enlarge my graph. So the first thing I'm gonna pick is my line tool. And then by default, it's already on a solid line. You see the solid line by the paint can is already pressed. So that's on the solid line. If I had to change it to the dotted line, I'd have to pick that dotted line, okay? So I had 0, 2. So let me go to 0, up 2, and click. And then I had 4, 5. So go right 4 and up 5. All right, so I made my solid line. Now remember to paint it or to shade it, I click on the paint can, and then I go above the line and click, and y'all, there it is shaded. And you save that. Now, I didn't do the calculator yet, so let me show you on it. So let me clear everything out. Now, the only thing y'all remember, the calculator cannot do dotted lines. But I could go to y equals. Remember, I had 3/4, so I'm going to do the alpha y equals to make that look like a fraction. Hit enter. So I had 3 on the top, 4 on the bottom, arrow right, put your x, and then we had +2. Now to shade it, I'm going to arrow all the way left of the Y1. And I'm going to hit enter until I get a triangle that's bigger above. So that one right there, see how it's bigger on top of the triangle? That one shades above the line. So now I'm going to hit graph. And there you go. Now remember, you can pick points out of this, hit second graph to get the table. So you see, I did 0 and I got a 2. When I did 4, I got that 5. But y'all look at that. If you pick 1, you'd have to graph 11/4. If you did 2, you'd have to graph 7/2. If you did 3, you'd have to do 17/4. So if you don't like graphing in fractions, I would stay with them whole numbers, okay? All righty, y'all. So let's.
What do you mean stay? I'm sorry. What do you mean when you say you only need to use whole numbers?
Oh, okay. So let me go back to my calculator. I wanted whole numbers for my answers. That's why I did 0 and then 4, like the bottom of that fraction. Because I like to graph whole numbers like that. So see, when I was up here at 0, I had a 2. So I like them kind of whole numbers. If you'd have picked a 1 for the x, look at that. You'd had to try to figure out where that 11/4 was on that graph.
Oh, okay. Okay.
Yeah, I don't like to graph fractions. I'd rather graph them whole numbers like them 2s and 5s and stuff like that.
Okay, so you're saying like the negative, no, not the -2, but the 0 and the 4?
Would be my
No.
x. Now look
Okay.
at my, so watch this as I go down. My next x I would have picked. See how that 8's
8.
got a whole number 8?
Okay.
Or if you went in a negative direction, oh, let me get left on my x's. If I went negative, I would pick a 0 and 2 was the one I picked. Now -4, you get a -1, so that's
Mhm.
not too bad.
Okay.
Any multiple of 4, since that bottom was a 4, any multiple of 4 would give you a nice number.
Okay.
So basically we could graph with that -4, -1, or that 8 and 8 and still have gotten the same exact.
Because look on my graph.
That's what I was getting at. That's
Yeah,
the
let me go
question
back.
that I had to.
See how mine is? So if you did that -1, hold on, what was it? -4, -1. See, it's on the line down here. Or if you did that 8, 8, see how it's on the line? Any point you pick out of them 2 points will
That's
be
neat.
on that line. Now, y'all, this one, y greater than 5, you don't need to do no work on this. And this one cannot be done on the calculator. But what you got to remember, on this number 19, when it's an X and there's no Y, this is going to be a vertical line. Okay. The Y greater than a number was a horizontal line, but the Y's are not on the test. Number 19 will be X and it will be vertical line. So you're going to grab the line tool. Let me ask y'all this. Am I going to use a dotted line or solid line for this?
A dotted line.
So you go over here by the paint can and click it to that dotted line. Now remember, when X is greater than 5, it's going to be a vertical line at 5. So go find 5 on the X axis down here and put a dot. And then you can go anywhere up or anywhere down and put that second dot. So y'all, I usually go up 1, but I'm going to show you. I can go all the way up here and put my second dot on that line. I got my vertical line
So,
and it's dotted.
so how do you
now-
know if it's dotted or solid again? What makes it dotted or solid?
You see it says X is greater than 5.
Right.
If there's no equals under it, it's going to be a dotted line.
Got it.
It's got to have the equals on there to be a solid line, okay? Now, what's cool about this, I got to figure out where I shade. You see how that greater than is pointing to the right? That means greater than on the x-axis, I would shade to the right
Right.
side.
Mhm.
If it was less than, it would be pointing left, and I would shade to the left side, okay? But greater than shades to the right on the x's, and less than would shade left. All right, y'all, because look, all these x values we have highlighted, 6, 7, 8, 9, 10, all these x values are definitely greater than that 5, okay? All right, y'all, so save that one. So let's see. All righty, this one, let me get these numbers and I'll do this by hand real quick. And then I'll show you on the calculator. All righty, so by hand, they're already solved for the y's, so I would just figure out both of my tables for both of these real quick, and then we'll plot them on our graph. So these numbers ain't too big, so I'm going to go out about 5 again. Now, I'll figure out this line, plot it, and shade, and then I'll figure out this line. Now, for both of these, I'm just going to use zeros and ones, because those are easy numbers to add. So if we put a 0 in here, 0 plus 4 is a 4. If I put the 1 in, 1 plus 4 is 5. So my first line goes at 0, 4. So 0 up 4. And then 1, 5 is right 1 up 5. Both of these will be solid lines because you got these equals on them. That's greater than, so we're going to shade above the line. So now let me play with this second line. If I put a 0 in there, 1 minus 0 is 1. And then if I put a 1 in there, 1 minus 1 is 0. So my second line goes at 0, 1 right here. And then 1, 0. It's also a solid line. It's less than, so it's going to shade below this line. Okay, y'all, so look at where I'm double shaded at is right over here, this left little triangle piece. I'm shaded above and I'm shaded below that line. So watch me show you the answers before I do it by hand on the calculator. So see, they're only showing the double shaded areas. So on this one, I would definitely pick D, because mine was shaded above and then below on that one. So let's do it on the calculator. So I'm gonna clear out my y equals and clear out this key history. All right, so y1, I would put my x plus 4. And then I'm going to arrow all the way left because this one's shaded above. So I'm going to hit enter until I got my triangle that's bigger above. Then I'm going to come down here and put in my y2. So y2 was 1 minus x. It's shaded below, so I'm going to go all the way left of the y2 and hit enter until I got the triangle that's bigger on the bottom. So bigger on top above, bigger on bottom, shades below. I'm going to hit graph. And y'all look there, that left side, you can see that that left side triangle has double shading. So that's what we're going to pick. Now, this one you didn't have to graph, but if you did, watch this. If you hit second graph on this one for the table, okay, let me go down to the numbers I was using. I did zeros and ones, so I'm going to pull them on the top. So when x is 0, the first line was 4 for that y. When x was 0, the second line was 1. So it puts all the y values corresponding to those x values. See, I had 1 and 5 for the first line and then 1 and 0 for the second line. So it makes the table, but it puts the y1s and then the y2s, okay? But y'all, all you had to do is go to that picture, and then let's go back to MathLab. We would pick D. That's the only one double shaded on the left. And y'all, I ain't gonna lie. I've done this study guide a lot of times, and pretty much every time I've done it, it's been the one with the triangle on the left side. When y'all did your homework, wasn't it always that one like D? They move it around like A, B, C, D, but it's always the one pretty much shaded on that left side. Oh, y'all, it says submit, so we're done. So any questions on this? So yeah, we didn't miss any, did we?
So these are going to be all of the questions that are on the test.
Exactly. Same order, same everything.
Okay. And this is on Wednesday?
Oh, so Wednesday, I'm actually doing new material Wednesday. So this test is open for y'all. So do your review quiz first so that you get used to, because remember that counts as a quiz grade.
Okay.
So it'll say test 1 review quiz. The test is open also. And y'all, the test is due by Sunday night at midnight.
Oh, okay. Okay.
So I'll leave it open all week for y'all because some of y'all work and all that stuff. Now we will start new material Wednesday doing 7-1 and 7-2, but they're not too bad. So we don't want to overwhelm you on a test week. So 7-1 and 7-2 ain't that bad. And they neither one of them have support. So it'll just be 2 little assignments just to keep us on pace. But yeah, practice your review quiz and then play with that test, okay? So the review quiz you can do as many times as you want. So do that review.
When due?
Do what now?
When is the review quiz due?
Oh, the same day.
On Sunday?
Yeah.
Okay.
Mhm. And the review quiz, like I said, do it. Once you get a good grade on it, go knock out that test. Okay? Because you can do the review as many times as you want, but remember the test only gets one shot, okay?
I have a question on the test.
Uh-huh.
So, is it gonna tell you like right away if it's wrong or not?
No, once you see when I went through it, it wasn't giving me no grades until at the end when I submitted it.
Okay, good, because I feel like I'd have a panic attack.
Yeah, yeah. So you're gonna have to sweat through them 20 first, okay? And then once you submit it, you can it'll let you review and see if you missed any, okay? So yeah, do your review and sort of figure it out. You can print the review also. Once you do it, you can sort of see what you're doing wrong before y'all hit that test, okay?
Are we able to do the review over and over?
Do it now.
Are we able to do the review over and over?
Oh yeah, you can do it unlimited number of times on the review.
Okay.
Yeah, and we set it up like that so that y'all will play with that until you get a good grade, then knock out that test, okay?
And you said it's 20 questions?
Yep, same 20 we just did,
Okay.
okay?
All right, thank you.
So y'all just take a chill pill, you'll be all right.
Oh, Miss
Thank
Eugene,
you.
Yeah,
So-
I hear you.
we print off them little, the little practice sheets you had in the future. Can we
Oh
print them?
yeah. The
Like, you see how you had your little sheet, how you had your sheet? Could
Yeah.
you send it to us in the future?
It
Study
should
guide,
let
or
you-
no? Is that
it
not
should-
allowed?
that thing will let you print it out and then figure them out and then go put all your answers in too if you want.
Yeah,
Mm-hmm.
that's what I was asking. But yeah.
Yeah.
Okay.